We had our trials and tribulations, but we've made it. We've made it. One more to go. Closing with a bang here. Jack is connecting. And okay, just need you to unmute Jack, and I think we're good.
There we go.
Okay, there you go.
Ready to go. Hello. I'm Jack Ellis, and I'm the co-founder of Fathom Analytics. I also teach serverless Laravel, which you may have heard of. And today I'm going to talk about how we scaled Fathom Analytics to handle billions of page views every single month.
I will never miss a Laracon for any reason. I'm here in the Jack spot to talk to you about Static 3. Static 3 is a flat file CMS built on Laravel.
I don't know how we did that. Now, first things first, I want to apologise for a couple of things. Firstly, for the bags under my eyes. I was up till 2 AM last night putting down rubber gym flooring for the home gym. Additionally, I'd like to apologise for my room being such an echo chamber. You can just hear how crazy it is, right? Well, the scheduling just messed up. I'm taking part in an early access to this program called, Pimp My Office? And it's done by a rapper named Zzibbit. I don't know what the name is. It's something Zibbit. And anyway, what they do is they come in, they take your office apart and they put new things in. And he was in a show called Pimp My Car. So yeah, just bad scheduling really, but we're going to be fixed soon. So I do apologize about the echo. Anyway, the first thing I want to do is get started and talk about version 1 and how this all began. I love these transitions between slides, firstly. But anyway, so version 1, I got brought onto version 1. Myself and Paul Jarvis were actually working on something called Pico, and it was a medium competitor, you know what I'm talking about, a competitor to Medium, and it was going to be a Patreon meets Medium type thing, and we had thousands of people waiting for that. And then Paul's original developer upped and left to become a teacher. So Paul was in a position where he needed a developer. And I was in a position where I'm thinking, I don't want to work with a Go code base that is absolutely ugly. I've become very entitled. And now I know Go is very fast, but if you look at a Laravel code base, it's so organized and structured. You can't just go into all these files, .go. It just doesn't sit well. I'm sure I've offended a lot of people by saying that, but that's just how I feel. So version 1, I had to convert it from Go into a fresh code base. So I'm thinking to myself, I don't want to be running any servers. It's an analytics company. You can go viral all the time, and you don't want that. So what I did was I decided to use Heroku for version 1. And we deployed onto Heroku, provisioned some dynos, and things went pretty well. Having said that, we did eventually run into some problems where we were sharing resources, and occasionally someone would be hogging the resources. And because of that, performance would suffer, obviously. The main thing with this, for scaling at version 1, I said to myself, look, don't prematurely scale, because we all do that, right? We're working on a project and we think, well, what if it goes viral? Yeah, worry about that when you're getting closer to that. We were doing maybe $1,500 a month. We didn't have any big customers at that time. So thinking back to that, the main thing I cared about really was how do we have all this traffic coming in at the same time and how do we process it? So tip 1 is find a way to defer the processing so that if you are getting overloaded with traffic, you're not trying to do everything at the same time. So imagine you have a database. Don't just pound that database with every request you get. Find a way to keep that request super light. And obviously that means hand it off to the queue and have a job. But I'm even talking about the job as well. So within the job, find a way to just be done with it in less than a second and then accumulate it, and then you can actually process the data later rather than trying to do everything at the same time. So for Fathom, that meant that a page view comes in, we process it in the queue, and then we chuck it into this table called page views. And now page views just sat there until it was actually aggregated, and we built this this table of data, which was done by site ID, timestamp, that kind of thing. So that was a very important first step. And I'll talk about the problems we had in version 1. Now, I haven't got any code for you because we're going back to version 1 and I'm talking about what not to do. So I'm going to be talking about this and not showing you anything, just so you're aware. So version 1, one of the problems that we actually had was that we had a host name and a path name. So a host name might be usefathom.com and then the path name might be /blog, right? Now imagine you got 500 people visiting that at the same time and it all got put into the backlog. When we processed the backlog, we would have to get a foreign key for those strings, right? Because the way we stored it, in my mind at the time, it was me thinking, oh, I want to save space in the database. Absolute nonsense. I mean, that does save space in the database, but it wasn't worth it at the time. But anyway, I split it up so we had a host names table and a path names table. So then we'd reference it in the stats table through hostname_ID and pathname_ID. So that was fine, but what we had these, when we were running these background jobs, you would have it fighting over creating the host name and the path name. So you might have one area trying to create it and the other's trying to create it at the same time, and then you get a clash. And the solution to that was to just put an index on the table. Oh wait, you can't, because the the path names are a long text or a text. I forget which one. So you can't do an index on a long text. So I had to actually, this is so bad. So going back, I actually had to do an MD5 hash of the values in a separate column and then create a unique index based on that. So version 1 was a little bit messy and it wasn't my finest work, I must say. In addition to that, yeah, what did we do? We split up the collector from the dashboard. That was always something we did. So even now we use Vapor, we still do this, but moving the collector away from the dashboard so that they can run on different Vapors for different reasons, but Heroku, it was so that performance wasn't affected and we could scale up the collector independently of the dashboard. So problem number 2 with regards to the version 1 setup, when we did aggregation, what sorry, I can't laugh, I'm on a time limit, I shouldn't waste time. We would lock. When I say lock, I don't mean atomic lock or anything like that. I mean, we would update the table to mark the rows as locked, and we'd select however many of them we were going to do, and then we would loop through the locked ones, and we'd chunk through. I don't know why the heck I did that. At the time, I thought I was just so clever for thinking this thing through. But we did... Yeah, tip 2 is don't overcomplicate things. Keep it simple, stupid. So we chunked through everything, and that became a problem one time. And the reason I called this part Holiday Drama was because on the day that I was flying back to the UK, Holiday Drama, it was actually a business trip, but whatever. On the day I was flying back to the UK, in the morning, getting ready to leave, and everything goes wrong. Data isn't aggregating. I have no idea why. So that was a good start to the journey. I mean, flying internationally isn't stressful at all. So I could take as much of this as they could give me. Anyway, so yeah, it paused. So what we had to do was debug it, and it turns out the database had gone offline, and something had happened where a bunch of rows had become locked. Right, and not locked by MySQL, locked by my own code. It was a custom lock thing I'd written. So because of that, it wouldn't continue aggregation, and we had a big backlog piling up. So I had to debug that, and it took me ages to debug that, and I finally realized, and I hit myself in the head and said, "Don't do that again, stupid." So that's another tip: is don't complicate things. But I'm not going to talk about version 1. Version 1 was a long time ago. You know, we had to get it away from Go. We had to get it live so people could still use our service and pay us and everything, do the migration. But that was all whilst I was contracting. The real fun is when we get into version 2. Okay, I'm afraid we have lost my wonderful face as we hop over to this, but that's fine. Let's look at some code. Now, we dispatch our jobs to a queue and we use SQS. SQS is provisioned through Laravel Vapor and, you know, highly available, fault tolerant, infinitely scalable, that kind of thing. But guess what? It can go offline. So don't pretend like you're using a service that's never going to go offline, because it will. It will go offline. It has gone offline. It does go offline. It goes offline regularly. So when you use external services, don't just use them as if they're never going to go offline, because they do go offline. It happens. We wrap it in a retry because when we launched version 2, we had a few errors where SQS, I think like DNS issues or things like that. And I thought, what the hell? This is meant to be a highly available service. But the reality is that even if it goes offline for under a second, when you're doing high scale, you're going to run into these issues, okay? So my recommendation is to do a retry wrap around it. And now I'm quite boring. I just have a 25-second back off on each retry. You'll talk to a lot of people and they will recommend a varying back off. And you know what? I agree. I mean, I do it this way. It's working just fine. But if you want to do a varying back off, absolutely go ahead. So with this, we've seen no errors since we implemented this retry. So that's been fantastic. Now, coming into the construct of the job, it depends on what you're handling when you're talking about scaling requests. So in our case, we're receiving tons and tons and tons of page views. They're all coming in. And we don't actually have to return anything. So I'm going to be talking specifically to that. It's not someone doing a lookup for data on that API, on our API, for example. So what we do, and again, it's so important to remember that, I say and again, but in our situation, we are privacy by design, GDPR compliant, e-privacy compliant, all this kind of thing. So we have to be very careful with how we do things. So if you see this and you go, why doesn't he just store the IP, or why doesn't he just store this, that, and the other? We have to be careful. And, you know, we don't want to store the plain text IP address in the queue. So we do this all in the construct. Now, because we're getting so many people hitting this, we do not want to be hitting our database. Now, we actually, and most people do, but we actually use a fixed size database. Well, what does that mean? It means that we have a certain amount of CPU, RAM, and IOPS. And I'm sure people in the back are listening and they're thinking about my article the other day about how a customer who got 10 million page views caused us an interesting time. So if you've read that, you'll know about IOPS. So that was pretty funny. So these are things you have to be mindful about. So the objective is to put as little strain on the database as possible, because the database is the weakest point in your application. And we'll get onto that later. So with the hasher, you see we've got a hasher here. Now, I've written an article about this before. You can go to the usefathom.com blog and you can read a long time ago. It was something along the lines of how we built GDPR compliant analytics or something like that. I forget. Now, I'm not going to go into that because it's all privacy and that will bore a lot of people. But one of the main things we do here is we actually have the sort key and that hits the database. But you see, I cache it. You need to be doing caching, and a lot of you will sit there and go, yeah, no shit, Sherlock, we need to do caching. Yeah, but people don't cache. Not everyone caches. Don't sit back and think, oh, I cache, everyone cache. It's not the case. I've been in code bases where I've been asked to do audits and people don't use caching. And that's, this is important. This is why we talk about it. So you want to be caching any access to the database where you can, because as I say, database is the weakest point of the application. Okay, so let's talk about one of the first problems we had when we launched version 2. Now, this talk is not about, here's what you need to do if you want to scale. The best way to learn, I find, is by talking about problems and learning from those. So when we first launched, I was really proud of myself because I thought, oh, we won't have a backlog for this. We will actually do an insert or update on the table, on the stats table. What could possibly go wrong? Well, I'll tell you what goes wrong. This is our site stats table from 2019. What I did was I thought to myself, okay, well, what we'll do when we get a visitor coming in, we'll do it on the site ID and on the timestamp hour. Because what you can see here in our database is that we have the site ID, we have a total for page views and visits, sessions and bounce rates, and non-durations. You can see it in front of you. Now, the index on this table it consists of a unique index, and it's the site ID and the timestamp. Okay? So what we'll do is we'll attempt to do an insert, it's an insert on duplicate key update. So we'll do an insert into 849 site ID, 5 p.m. on the 31st of July, that top row. And then we move on to the updates. But if you have loads of people viewing at the same time, so imagine you get 100 visitors coming in and you try and do all of that on the actual request, even in the job, by the way. This wasn't on the actual incoming request, it was in the job. They all fought over trying to lock that index and update it, right? They can't update that index at the same time. So what happened was we ran into all these different deadlocks. And then when we launched version 2, I'm seeing all of these deadlocks and I'm thinking, what on earth is going on here? So that was fun because in staging and in testing, we didn't have this issue because obviously we didn't have as much traffic. But trust me, you do not want to be doing this. So this actually brings us on to our next problem, which is more interesting, which I've shared with someone before. And I think it's going to be a challenging problem to explain, but when we ran into this deadlock issue, we decided, okay, we'll go fully with the backlog method, okay? So all traffic coming in went into our backlog, went into the page views table, and that was that. But then we moved on to a new problem. What do we do when we have such a big backlog that if one site goes viral, it delays all of the other sites from being processed? So if we have, I don't know, Google wouldn't be our customer. If we had a huge site and they were getting lots of traffic, their traffic would drown out Fathom's traffic, right? Or jackellis.me's traffic, or Laravel.com's traffic. And then you wouldn't actually be able to see your stats because they wouldn't be getting aggregated. This has happened. But how do you solve it? So before I go into this, let me explain how we did things before. We had it so that there was a single cron job, or scheduled task, I should say, that performs the aggregation. It goes through the page views in the database, pulls them out, and it sums them up in the index. You know, the index that I just showed you? It does it by site, it does it by path name, and it does it by referrer. And this works great when you have a small amount of traffic in the backlog. But when you get a bigger amount of traffic, as I just said, what happens is the bigger clients completely drown out the smaller clients. So you have person A, and they're getting under 100,000 page views a month. Actually, let's say you have 1,000 person A's. They're doing less than 100,000 page views a month, okay? But then you have one person B who's doing 20 million page views a month. What then happens is that their page views can often drown out some of the smaller customers. So in the aggregation, it orders it by ID and processes it. But people will get drowned out. So you might have the first section will be some page views from the popular customer, and then it will go to the less popular sites, and then it will go, the next 10,000 page views might be the popular customer again. So they're just fighting to get aggregated, and that just won't do. So then it brings us to a whole new problem that we have to solve, where we need to scale this cron job, this scheduled task. And anyone you talk to will tell you cron jobs do not scale. So you have to be careful. So here's what we did. We created a group column on the sites table. Now you can see that it's 1-1, and that's because Fathom and serverless Laravel are in the same group. Now, the purpose of the group, the objective was, how do we process viral sites at the same time as other customers without blocking their aggregation up? Well, instead of having a single threaded aggregation, we broke it up into multiple groups, and for each group we have, there is a different thread. So we could have 500 to 1,000 customers with low traffic sitting in a single group, and the aggregation wouldn't be delayed. It would be absolutely fine. But then if you have a bigger customer who's perhaps doing 15 million to 20 million page views a month, we put them in a separate group. So as you can see in this code on the left-hand side, I go through the sites table, and this is the way I do it at the moment. I can definitely improve on this. I know this, but this was the first proof of concept, I guess, when we built this. So we grab the distinct groups, we pluck them into an array, and then we just loop through them. So at present, we have less than 200 groups. I don't even know how many groups we have. We have less than 200 groups. So looping through them works absolutely fine. In the future, if we have 1 million groups, then things may change, although that's not going to happen since we're changing things up for version 3, which I'll talk about. So we loop through the groups, and what we do, let's go to the schedule resolution aggregation. So what we do is we just run this check to see if it's available. Now, all I do is I just keep something in DynamoDB in the cache, and I just track whether the group is locked. Now, the reason I do this is because I don't want sites to be competing for the index. I mentioned that issue. We don't want to be having multiple aggregations running for the site stats table on group 1, because guess what? We run into the index clash. So all we do instead is we check to see if the group's ready. If it is ready, we lock it. Okay, and this cron job only runs once every minute, and there's no overlapping. So we can lock the aggregation group. Fantastic. That's now locked for a few hours or whatever it may be, and we can dispatch a job. In this example, we're using resolutions. So we can come over to here, and we go through all the sites that are in the particular group. And then we load 2,000 entries, chunk them into chunks of 50, and then we do the insert on duplicate key updates, and then we remove them from the backlog. Okay, and then if there's a failed job, you can see here that we release the aggregate group lock, which is fantastic. So that's how we can scale a cron job and make it multiple threaded, if you like. So yeah, that's been huge for us. We no longer run into this issue with the big backlogs. And interestingly though, if you've read my recent blog post, you'll learn about a customer who went crazy viral. Now, they're interesting because we now have a big backlog, even at this moment that I'm speaking. We now have a huge backlog where they're in a dedicated group, but we're still running into problems where we can't aggregate them and keep them up to date. So what this system may actually develop into is doing it by the hour. Because remember, the index is done on the site ID and the timestamp, but the timestamp is done on the hour. I don't know if I mentioned that, but that's how it is done. So it isn't done daily, it's done hourly. So you could split this thing up and you could do the aggregation by the hour, right? And you could have different jobs for each hour. It does get a bit more complicated, but honestly, when you're dealing with this kind of scale, it's a lot to do. So I can't do this talk without talking about our infrastructure. I submitted 2 talk requests for Laracon, and one of them was about Laravel Vapor, and I was going to spend 30 minutes talking about Vapor. And Taylor obviously didn't want that because that is pretty commercial and it's promoting a product, but I can't not talk about it. Before my course existed, you go back and look at our blog. I was loving Vapor. Go back to usefathom.com, go on our blog. I talked about moving to Vapor. This was before my course. The course only came, so my serverless Laravel course only came because I was getting hundreds of emails from people off of that blog post. Otherwise, it wouldn't exist. I love Vapor. So we've gone from, I've got to worry about servers. How many servers do I need to provision to handle all the traffic? Will we scale? Do we have enough CPU? Do we have enough RAM? We don't think about that. The only thing we really think about is the database, but I'll talk about that later. So with Vapor, we have a collector and we have our dashboard, right? Our collector, we have it at around, I think, 1 gigabyte of memory per invocation, if I recall correctly. Now that collector, because we do this, the collector sits there with its dedicated queue, its infinitely scalable HTTP layer. I will add a caveat and say that you do need to speak to AWS and get your concurrency limits increased if you do want to have some true scale. You can choose to limit it if you would rather your requests fail. Imagine you got like a DDoS attack or something and AWS didn't detect it. You'd want to have some kind of concurrency limit in place, but we don't really care about that, to be honest. We can absorb the cost. It's not a big deal. So we don't think about servers. We've got some custom domain servers that run Caddy, which we have to do because of SSL certificates and limits and AWS and that kind of thing. But apart from that, our collector just sits there. It takes in the traffic. Our queue runs at infinite scale. Redis, we have Redis provisioned quite high and it does what it needs to do. So we don't worry about anything server related. I know a lot of these talks you will see people, they'll go into the servers, this, that and the other, HTTP, what are you running, Nginx, Caddy. We don't care. We literally deploy it and it just runs. So I've got nothing fancy to talk about this. Deploy your application to Vapor. This is not paid. I'm not paid to say this. Go with Vapor, seriously. So we don't worry about servers. That's pretty much it. So that's obviously a huge cop-out, me talking about using Vapor because Vapor makes things easier, but it ties into how we scale, right? We don't worry about servers. Servers are boring. So that is a cop-out, but just use Vapor. Anyway, you got to use database transactions and retries. As I've said, always assume your dependencies are going to break. Cache everything you can. Reading from cache-based storage, like cache-based, key-based storage, like Redis or DynamoDB, is always going to be a lot faster than hitting your database. You want to avoid these complex queries whenever you can, okay? If you're using AWS RDS, then you got to make sure you're keeping an eye on your IOPS, because recently someone actually had problems with their IOPS and that wasn't fun. So let's talk about what we're currently struggling with, okay? We're currently struggling with reporting on such huge amounts of data. And before you say, have you got your indexes in place? Yeah, of course we do. But the data is for tons of pages. And yeah, there's so many. So, for example, a public customer who's public of ours, jsfiddle.net, they've given us testimonials so I can talk about them. JSFiddle, for those of you who know what JSFiddle is, what happens when you create a fiddle or like a snippet? The path name is different. So JSFiddle is a very popular site in our community, in all communities. So for each page they have, and they've recently, if you look at their source code, you can see they've recently changed this and they've done a very clever solution where they actually don't track the fiddle. But that wasn't always the case, right? So when you're handling this many path names and you're having to group by and sum, it's hard. And we allow custom on-demand aggregations too. So you can't just roll things up. And because one idea I had was, what if I just keep a rolling total over the course of various days? But you can't do it because then you need to do a diff between. It just gets too complex. So we can't do that, and we have to do sum and group by, and that sucks. So we've been speaking with Peter I'm going to say it properly. Peter Steinbergen. Nope, that's wrong. Peter Steinbergen. And he's like Elasticsearch genius. He's a member of the Laravel community, and he's helping us move to Elasticsearch. Now, the reasoning behind this is because we need to handle these queries better, and it's going to be much better than MySQL, and we're going to use a managed service, and it can scale on demand, instantly, zero downtime. So a huge win for us. So I definitely would advise, if you're doing all these queries, aggregations, that kind of thing at scale, look for a different option. MySQL is really not going to do it at scale. It's just not. I mean, it can do it at some scale, but it depends on the amount of data you're using, right? And I know there are other options for tech, but we're going with Elasticsearch, so please don't tweet me asking me about, ClickBase and everything else, okay? And I will say as well, Peter's been great, and he has got a course coming out, which I persuaded him to make, and it's basically an Elasticsearch course tailored to Laravel developers. So if you go to elasticsearch.laravel.com, I recommend it. He's a very smart guy, and he's a very, very nice guy. So that will solve that issue on our dashboard, and then we're going to be moving to that over the next few months, probably before version 3. So I'm very excited about that. Now, the biggest problem we have at scale, right? It's not the HTTP layer. Lambda auto scales, easy peasy lemon squeezy. SQS infinitely scales. Redis, we do have a fixed size instance, but Redis we've got heavily over provisioned. So key-based storage, I'm not too worried about that, and we could switch to DynamoDB if we wanted to. For key-based caching. So that's not really an issue. The big issue is the bloody database. The IOPS, the CPU, the RAM. Honestly, I'm sick of it. So we're currently paying too much money for our database, and it's over-provisioned. And then when we talk about serverless, the whole point of serverless is that you're paying for what you use. You don't want to over-provision things. So I'm pretty much sick of it. So we don't ever want to have to worry about limits. So we're actually moving to DynamoDB, and some of you already know about this. If you follow me on Twitter, @Ellis, you'll know about this. So we're going to be using DynamoDB, and we're going to basically be able to handle infinite scale on our database. So we'll then have Elasticsearch and DynamoDB. And I hear you say, but isn't DynamoDB just for caching? We know about DynamoDB. It's a cache driver in Laravel, but it can actually have full applications in it. Amazon, for example, for their tier 1 services, they use DynamoDB. So it can be used to power your whole application. And now I know most of you will listen to Adam Wathan's Full Stack Radio, and he had Alex Debris on for an episode about DynamoDB for applications. And I listened to him, and I was confused because he was talking at such a high in-depth level that I couldn't actually tie anything he said. And Adam was trying. Adam is a fantastic interviewer. And Adam was he kept on bringing Alex back to tie it into Laravel or relational databases, but it's hard. It's a huge jump to make. And I messaged Alex and I said, dude, you're so in-depth with this stuff. We need to tie it to how we as Laravel developers actually build applications. We use MySQL and Postgres. So I actually have something to share. We have a new course coming out. And I say we. I'm actually working with Alex Debris to build a course that teaches you how to use DynamoDB at infinite scale, which is stupidly exciting. We haven't seen this in the Laravel space. Vapor is gaining more popularity, and people are caring about serverless more because people don't want to use servers. They don't. So Alex and me are going to work together to actually connect everything he knows, and he knows a ton. This is like an AWS data hero. This guy's worked at serverless.com or whatever it is. He's got crazy knowledge. And I'm going to tie it into Laravel, and we're going to teach you how to use it. And it's going to be incredible. So make sure you sign up at dynamodbforlaravel.com. And that wraps things up. It's hard to get things in a 30-minute slot, but I covered some basics. And if you have any questions, just tweet me at Jack Ellis on the old Twitter. Now, make sure you check out Fathom at usefathom.com. Laravel in your goodie bag, or what is it called, swag, you can actually get $20 credit. If you're an existing customer, send us a support email and ask for it and we'll give it to you. If you're a new customer, if you follow the affiliate link, you'll get $20 credit, which is pretty cool. Make sure you check out serverlesslaravelcourse.com / and I believe it's / Laracon 2020, and you will have $100 off of my serverless Laravel course. This is the course that I put together after using Laravel Vapor, loving it, blogging about it, and everyone else is like, oh, I want to use Vapor. So the course will basically save you, it's my hundreds of hours compressed into a course to save you a ton of time. So you should check it out. Yeah, so I hope you enjoyed the talk, and see you soon.